Hi everyone, myself 18 Naveen Prasad, Assistant Professor, Department of Mechanical Engineering, Vellalar College of Engineering and Technology, Erode. Today in this session, I am going to discuss about the basic working principle and components of turbocharger and supercharger. So moving on to the introduction, the power output of an engine depends upon the amount of air injected per unit time and the degree of utilization of this air and the thermal efficiency of the engine. So the indicated engine power is given by PLANK divided by 60,000. So IP is equal to IP is equal to PLA small n into K divided by 60,000, where IP is the indicated power in kilowatts, capital P indicated mean effective pressure, Newton per meter square, and L is the length of the stroke, capital A is the area of piston, and small n is the number of power stroke. For two-stroke engine, capital N is the RPM, and for four-stroke engine, RPM is taken as N capital N divided by 2, and capital K is nothing but number of cylinders. Three possible methods utilized to increase the air consumption of an engine as follows. The first thing is increasing the piston displacement, and next thing running the engine at higher speeds, and last thing is increasing the density of the charge. By increasing the piston displacement, which increases the size and weight of the engine and introduces additional cooling problems. Running the engine at higher speeds, this shows that the results in increased mechanical friction losses and imposes greater inertia stresses on engine parts. And last thing is increasing the density of charge. This is the most important. So increasing the density of charge, this allows the greater mass of the charge to be inducted into the same volume. So the greater mass of the charge will be inducted into the same volume of the engine cylinder. So definition, so the most efficient method for increasing the power of the engine is by supercharging. That is by increasing the flow of air. By increasing the flow of air into the engine to enable more fuel to be burnt. By increasing the flow of air into the engine, which is used to burn the more amount of fuel. So in this case, we are going to discuss about the supercharger and the turbocharger. In case of supercharger is run by a mechanical drive, which is powered by the engine power. And in case of turbocharger, turbocharger uses the exhaust gas to drive the turbine, which is directly connected to the compressor in the air intake system. So the exhaust gas is used to run the turbocharger device. The exhaust gas is directly passed over the turbine section, and that the turbine and the compressor is connected by a coaxial shaft, and the compressor will compress the fresh admitted air, and compressed air is passed into the engine. So this is the schematic view of turbocharger. So this portion, from this figure, the right side portion, which is indicated by the red color arrow mark, it is the turbine section. This turbine section is run by the engine exhaust gas. We will have a turbine housing also. So after the exhaust gas from the engine is allowed to the turbine section, which strikes on the turbine blades, and it will start to rotate. After that, the exhaust gas will be passed to the outlet. So the compressor section and the turbine section is connected by an coaxial shaft. So it makes the turbine the shaft from the turbine, which is connected with the compressor section, which on moving the on a rotation of the turbine section, it makes the compressor to run. So the compressor sucks the ambient air into it and starts to compressor. So the the compressed air from the compressor section is passed into the engine air intake system. So this is the main simple working principle. So in this, from this diagram itself, we can say that three components. One thing is turbine. So next is compressor, and next thing is the shaft. So what is the need of turbocharger and supercharger? So for ground installations, it is used to produce a gain in the power output of the engine. For aircraft installations, in addition to produce a gain in the power output at sea level, and also enables the engine to maintain the high power output as altitude is increased. So the working principle of turbocharger. So a turbocharger is a small radial fan pump driven by the exhaust gases energy of an engine. So it consists of, already I already discussed about the components. It consists of turbine, compressor, and then shaft. So the turbine converts exhaust to rotational force, which is in turn used to produce a compressor. The compressor draws the ambient air and pumps into it in an intake manifold at increased pressure, which results in the greater mass of air entering into the cylinder of the engine on each intake stroke. So types of supercharger based on the use of compressor. So based on the use of compressor, it is classified into three types. One thing is centrifugal type, next Roots type, and the van type. The components of turbocharger: air compressor, turbine, and then intercooler. So the intercooler is used to cool the excess intake air from the compressor. So due to the compression of compression of atmospheric air in the compressor, the air may get heated. So the intercooler is used to remove the heat from the compressed air, which is after that, which will be sent into the engine intake system. So advantages of supercharger and turbocharger: it more increases the pressure of the intake air above the local atmospheric pressure, and the more power of the engine produces. Automotive superchargers for street use typically produce a maximum boost power between 0.33 to 1.0 bar, providing an proportionate increase in power. Engines burn air and fuel at an ideal, which is nothing but the stoichiometric ratio of about 14.7:1, which means that it may burn more air. This is particularly useful at high altitudes. Thinner air has less oxygen, reducing power by around 3%, and 1,000 feet above sea level. But a supercharging can compensate for that loss, pressurizing the intake charge to something close to the sea level pressure. So disadvantages of supercharger and turbocharger. So when compared, so the cost wise and the cost and complexity is high. So detonation, parasitic losses, space, and last thing is the turbo lag. So John Deere, we have already know about the John Deere tractor. So in this also, in the 1919, the John Deere tractor has been performance evaluated with the turbocharger. So these are the engine specifications. So this is the simple sketch which can be easily which is used for easily understanding. So this is the IC engine. So the red color gases are nothing but the exhaust gases. So the exhaust gas from the engine is directly passed into the turbine section. So this exhaust gas strikes the turbine blades, and this while striking, it starts to rotate the turbine blades. So the turbine is connected with the compressor by using an shaft here. So in this area, we will have a shaft. So the ambient atmospheric pressure is drawn into the compressor section. So here the more air will be sucked and passed into the intake manifold of the engine. Before passing into the engine intake system, we will have an intercooler. So the air gets cooled. The air gets cooled. The atmospheric air from the atmospheric sucked and compressed air from the compressor is cooled before reaching the engine combustion chamber. So the intercooler is used to reduce the temperature of the air. So conclusions, due to low speeds of operations is less power in agricultural tractor, turbocharger is used, not supercharger, for more power generation and it to operate at higher altitude. A turbocharging tractor engine is an acceptable method of increasing its performance if carried out within manufacturer specifications. Lower engine operating temperatures result which can be beneficial since the engine lubricating oil is subjected to higher temperature as it passes through the turbocharger. The correct oil must be used as specified for turbocharged engines. Thank you.